In this video, we're going to look at rotations. A rotation turns a shape about a fixed point called the center of rotation. Most often, that center of rotation is the origin. A shape and its rotation are congruent, meaning they are the same shape and the same size. That should be similar. That should sound familiar to translations and reflections, because the translation, a reflection, and a rotation, they're all congruent transformations. They all have that in common. However, they each have a difference. When we talked about translations, we said that those shapes faced in the same direction. Then we looked at reflections, and those shapes faced in the opposite direction. And now we're going to look at rotations, and the difference there is shapes may be turned in a different direction. Once again, there are ways we can memorize how the coordinates change with the rotation, just like with the reflection and the translation. And also we can do it on our graphs. We'll look at some examples in just a minute. So if we look here, let's look down here for a second. There are clockwise rotations and there are counterclockwise rotations. What they're meaning by clockwise and counterclockwise, if you think about an analog clock, so a clock that has a minute hand and an hour hand, clockwise is how that minute hand or the hour hand, the hands on the clock will rotate. That's clockwise. Counterclockwise means the opposite of clockwise, so it'll be going in this direction, okay? So sometimes they'll ask you to do both, and it's good to know how they compare. So if they ask you 90 degrees clockwise, that's the same as 270 counter. 180 is the same no matter which direction you go. 270 clockwise is the same as 90 degrees counterclockwise, and 360 is the same either way. How the coordinates change on these clockwise rotations, okay? These would be really, really good to memorize, because a rotation, sometimes it can be tough to know exactly where each point should go. So how the coordinates change, these are all for clockwise rotations, okay? So if you memorize this and they ask you a counterclockwise question, just use our chart here. So if they ask you to rotate 90 counterclockwise, well, you can think about the 270 rotation rule with what happens to the coordinates, okay? So if we take a look at our chart, it says if we do a 90-degree clockwise rotation, if we look at our coordinate, the x coordinate becomes opposite, and then we flip the coordinates, okay? So the best way I know how to describe that, 90 comes before 270 in numerical order, x becomes before y in alphabetical order. So on a 90-degree rotation, you make your x coordinate opposite, and then you flip your coordinates. On a 180, your coordinates stay in the same place, x, y, they just become opposite signs. So if we had a positive, positive, now it's negative, negative. If this was negative, negative, now it's positive, positive, okay? On a 270 rotation, similar to 90, all right, but now remember 270 comes after 90, y comes after x, so we make our y coordinate opposite, and then we flip the coordinates. And the last one's pretty easy. If you do it at 360, you're back in your original starting point, so your coordinates will stay the same. So we'll look at some examples, and we will do something where we turn our paper to help us graph the new image, and we'll also look at how the coordinates are changing. So on number one, it says rotation 180 degrees about the origin. So let's talk about this in terms of our coordinates and how they change if we were to memorize that. So on a 180, our coordinates go from x comma y to the opposite of x and the opposite of y. So all we do is we change the sign of each coordinate. They stay in the same place. So a good place to start is to write down each coordinate. So Q, H, and J. Q is 0, negative, 1. H is 1, 2, 3, 1, 2, 3, 4, 5, negative. So negative 3, negative 5. And J is negative 1, 2, 3, 4, 5, 1, 2, 3. So negative 5, negative 3. So now we know that those are all going to change by just making opposite, right? So what's the opposite of 0? 0 just stays 0. The opposite of negative 1 is positive 1. Opposite of negative 3 is positive 3. Negative 5 becomes positive 5. Negative 5 becomes positive 5, and negative 3 becomes positive 3. And so now we can graph those new points. So Q prime now would be 0, 1. So there's Q prime. H would be 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. So H prime. and j would be 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. And there's j prime. And we connect those q to h, q to j, and h to j. And there's our 180-degree rotation. So if we think about it, they didn't ask us to go clockwise or counterclockwise because we end up in the same place. So 180, we need to know that each quadrant is like a 90-degree rotation, right? Because if I go all the way back here, that's 360 degrees. So this whole entire graph here, these 4 quadrants are adding up to 360 degrees. So if there's 4 quadrants, divide 360 by 4, and each quadrant is worth 90 degrees. So if I think about rotating this shape 90 degrees, let's say I want to go clockwise, so I'd end up there. Okay, well, another 90, I would end up there. And so now we know we're in the correct quadrant. So let's take number 2, and let's do it a little bit differently. Rotate 90 degrees counterclockwise about the origin. Well, counterclockwise means that I'm going to be going this way, would be clockwise, so I'm going to be going back the other direction counterclockwise. So I can think about this as 90 counter or 270 clockwise, okay? Either one of those are the same thing. I know that I'm going to end up in this quadrant right here, okay? That's where I'm going to end up. So another way for us to do this is to rotate our paper so that we have a new reference line. So let's think about this. Here's our original shape. It is in quadrant 1. We want our new shape to end up in quadrant 2. So by looking right now at our paper, quadrant 1 is the top right quadrant. Quadrant 2 is the top left quadrant. Another way for us to do this is to rotate our paper so that quadrant 2, or our destination, is the top right quadrant. So let me show you what I mean. If I rotate my paper like this, is my destination quadrant now the top right? Yes, it is. So now all I have to do is plot these same 3 points as if my graph was facing this direction now. So let's go back and let's write down our coordinates. So B, S, and L. B is 1, 2, 3, 4, 1, 2, 3, 4, 5, 4, 5. S is 2, 2, and L is 1, 2, 3, 4, 5, 0. Okay, so now we want to make this quadrant be top right. So we rotate it, and now this is our top right quadrant if we're looking at it the way our graph is turned. So now we graph these same 3 points, and they're going to automatically be in the correct spot because of how we've turned our graph. So B is 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. And this is B prime. S is 1, 2, 1, 2. S prime, and L is 1, 2, 3, 4, 5, 0. So now we connect our points, our vertices, and we have our rotation. So we can see how our shape was turned to give us our new shape. So there's 2 ways to do this. If you do it this way, you don't have to rotate your graph. You just write your points down, you use your memorization to tell what happened to the coordinates, and you graph those new ones, okay? If you choose to rotate your paper, then you write down the original coordinates, turn to have your destination quadrant where your original quadrant was, and graph the same 3 points, okay? So we will do 2 more, 1 each way. All right, so let's do number 3 like we did number 1. It says 90 degrees clockwise. So for 90 degrees clockwise, we know that our original points, X comes before Y, 90 before 270, so X becomes opposite, and then we flip. So this becomes Y negative X. So let's write down our original coordinates. So we have F, we have B, M, and H. So F is negative 1, 1, 2, 3. Negative 1, 3. B is negative 1, 2, 3, 4, 5, positive 1, negative 5, 1. M is negative 4, negative 2, and H is negative 1, negative 2. Okay, so let's see what happens when we apply our principle here. So X becomes opposite and then flip it. So 1, 3, flip it, 3, 1. 5, 1, flip it, 1, 5. This is -4. So 4, -2, flip them, -2, 4. 1, -2, flip them, -2, 1. So now let's graph our new points, okay? So we graph, F is 3, 1. So 1, 2, 3, 1, F prime. B will be 1, 5, B prime. M is -2, 4. 1, 2, 1, 2, 3, 4, M prime. And H, -2, 1. 1, 2, 1, H prime. So now we connect our points and we get our new shape. And that was our 90 degrees clockwise rotation. All right, number 4. Now we'll do number 4 like we did number 2. So let's write down our original coordinates to start off with. We have U, we have H, and we have F. U is -1, 2, 3, 4, 1, 2, 3, 4, 5. So -4, -5. H is -1, 2, 1, 2, 3. So -2, -3. And F is -1, -5. All right, so now we're going to turn our graph. So let's look at what they want us to do, 270 clockwise. So let's think about where we're going to end up. So if we're going clockwise, that's 90, 180, 270. So this is our destination quadrant, okay? So our shape starts on the bottom left, or quadrant 3. We want it to end up in quadrant 4. So now let's turn our paper so that this quadrant appears to be over here. So if we do this, now it's bottom left. Where did our shape start out? Bottom left. Where do we want it to end up? Over here. So now we have to make this quadrant appear to be bottom left. We do that by turning our paper. Okay, so now we're going to graph these same 3 points as if now this was the direction our graph was facing. So U is -4, -5. So -1, 2, 3, 4, 1, 2, 3, 4, and 5. Okay, so that's U prime. -2, -3, 1, 2, 1, 2, 3. And that is H prime. And then -1, -5. And that is F prime. Connect our dots, our vertices. And we can turn back and we have our new shape. So we can do it either way. You can either memorize what happens to the coordinates on 1 and 3 and just write those down, change the coordinates, graph the new points, never have to turn your paper. Or if you like turning your paper, if you don't like to memorize the coordinates, then all you have to do, write down your original points, turn your paper so that your destination quadrant is in the same place as your original quadrant, and graph those same 3 points, okay? Now, let's look at these rules down here and see if we can identify what's happening to these shapes, okay? So on number 11, we have our primes right here. So these are our primes. So we know that's our new shape, that's our original shape, okay? So if we see our shape went from this quadrant to this quadrant. So if we rotate this much, we would say that's 90 degrees clockwise. Or we could say 270 degrees counterclockwise. Either one would be good. All right, here's our primes right here. So this is our new shape. This is our original shape. So we either went 270 clockwise, or we could say we went 90 degrees counterclockwise. Right here, anytime we're diagonal from each other, that's a 180 degree rotation. It doesn't matter if we say clockwise or counterclockwise. And here's our primes. So this is the new one. This is our original one. If we go to right there, that would be 90 degrees clockwise, or we could say counterclockwise, 270 degrees counterclockwise, okay? So remember with the rotation, we are turning a shape, right? The key thing with rotation, reflection, and translation, the shape stays congruent. Same shape, same size. Translations are the same direction. Reflections are the opposite direction. Rotations are turned in different directions. This would be a good chart to memorize.